Okay guys, so today we're looking at section 2.2. This is in your student journal on page 31. We're going to be looking at parts of the parabola. We're going to be looking at things called the axis of symmetry. We're going to look at the difference between standard form versus vertex form. We're going to talk about the minimum and maximum values. And then later on tomorrow, we're going to talk about the intercept form. So for now, we're just going to be working on these first four. We're also going to look at how do we find the vertex of a parabola if it's in the standard form. How can we find that vertex if the parabola is not in that vertex form? So just to review, vertex form was this. Vertex form was for a parabola is y equals a times x minus h squared plus k. But if this has been all multiplied out, if we square this binomial, multiply by a and add k, we can get it into the standard form. So the first vocabulary word we have is axis of symmetry. This is going to be the line that divides the parabola into mirror images. And it's always going to pass through the vertex. As you're copying that down, I'm just going to explain that axis of symmetry. So suppose we have this axis. Here's the vertex right here at 3, 1. And we'll say our parabola opens down. The axis of symmetry creates the mirror images. So it comes right down here like this. Does anyone know the equation of that line right there? The equation of that axis of symmetry? Isaiah?
X equals 3.
And how did you know that?
Since it's a vertical line, its equation is x equals a number. Since the x-axis of the vertex is 3, x equals 3.
Right. All vertical lines, guys, have to go x equals some number. Can you see how right here, this would be the point 3, 0, 3, negative 1, 3, negative 5, 3, negative 10. Everywhere on here, x equals 3. That's why that's the equation of that, x equals 3. Standard form of a parabola is f of x equals ax squared plus bx plus c. And by the way, the a, it can be positive or negative. The minimum value, this is going to be the y-coordinate if the parabola opens up. So I already have a parabola that opens down. What if I had one that opened up? And let's say this point right here is at 3, negative 4. So when our parabola opens up, we have a minimum, and it's the y-coordinate of the vertex. So right there, negative 4, that would be our minimum here. The maximum value is going to be if our parabola opens down, like this. Right here, that's going to be our maximum value of 1. Intercept form, this is what we're going to talk about later. Right here, this is going to mean that P and Q are x-intercepts. All right, so our core concepts right here. Y equals ax squared plus bx plus c. If a is greater than 0, that tells us that the parabola is going to open up. Because what's that telling us about a? If a is greater than 0, it means a is what? Positive. And if a is positive, it opens up. If a is negative, it opens down. What if a equals 0? What does that mean? Tim, you were starting to say something. If a is equal to 0, what do you think?
There would be no parabola.
Say it again?
There would be no parabola.
Correct. What would there be? Instead of having a parabola, what would we have? If not necessarily. If A and B are both 0, then we'd have a horizontal line. But if just A is 0, then we're going to end up with something like 5x plus 4. Just any oblique is what it's called. Any line. All right. Let's look here. The axis of symmetry is always going to be x equals negative b over 2a. That's new. And we'll talk about why that is here in just a minute. And here's the vertex. This is probably new for you too. When our parabola is in standard form, we first of all find the x-coordinate of the vertex. We do negative b over 2a. This is just saying we plug that in to find out what y equals. All right, so we find the x value by doing negative b over 2a. We plug that x value into the function to find the y value. Does this negative b over 2a look familiar? Where have you seen it before? Quadratic formula, yes. The quadratic formula is this. You don't need to know it now, but just try to remember. It's negative b plus or minus what? Square root of? Good. So right here, that's always the vertex of the parabola. This has to do with finding the x-intercepts. That's what the whole thing does. All right, so notice here, this is opening up. We would have a minimum. Here's our axis of symmetry. That's equal to the x-coordinate of the vertex. If I wanted to find the y-intercept, I'd plug in 0 for x. All right, I'm going to do an example with you, and then I'm going to have you guys do one on your own. So let's do this example over here. Let's say our function is f of x equals negative 2x squared minus 12x plus 5. So this is our parabola. We're going to find the vertex. So to find the vertex, I have to look, here's A, B, C. I have to do negative B, so negative 12 is going to make it a positive 12 over 2 times negative 2. 2 times negative 2 is negative 4. So what's that going to give us then for the vertex? Negative 3. So now to find the y-coordinate that goes with the vertex, I have to plug back in negative 3. So I have to find f of negative 3. So that means wherever I have an x, I have to replace it with a negative 3. So negative 3 squared is 9. 9 times negative 2 is negative 18. Negative 12 times negative 3 is plus 36 plus 5. So I'm going to have 41 minus 18. I want to do 41 minus 20 and then add 2. 41 minus 20 is 21. Add 2 is 23. There's going to be my vertex. Now, I want to show you how you can check this. Follow along with me on this. Go to your calculator. Clear out your y equals. So we're going to type this in. Negative 2x squared minus 12x plus 5. We're going to do a zoom 6 to get the standard screen. Here's what I see. I'm not seeing the top of my parabola. I think the vertex is way up there at 23. So I'm going to go to my window. I want to make the y go up higher. If I want to see a high value of 23, I want to make this like maybe 26. Now just hit graph. Don't do zoom 6 or it's going to go back to the negative 10, 10. Just hit graph. And here's our parabola. I want to check that vertex. When you take a test, you might be able to use your calculator. You can check this vertex. We go to second, calculate. Here are our options. What is that vertex going to be the same as? Look at it again. Is it the minimum or the maximum on the vertex? Maximum. So I go back, second, trace, calculate, go down to maximum. It's going to say left bound. You want to arrow over to the left of that high point. So go to the left of it, hit enter. Go to the right of it, hit enter, and now it's going to say, is the guess in between these two arrows? We say yes by hitting enter, and right there it is. This is always going to try to find it exactly. It counts the pixels, but it's going to be a little bit off. The true vertex is -3, 23. You never use those numbers after that integer, unless it's like -2.5 or something, you know what I mean? So we checked our vertex, so we're correct. What would the axis of symmetry be then? There's our vertex, axis of symmetry. Abby, do you know what the axis of symmetry would be? Okay, but you don't have to do all that, because remember how it goes through the vertex?
Yeah.
So what's it going to be? X equals, what does X equal?
-3.
There you go. See what I mean? Don't waste time doing it that other way. Okay, what about the Y-intercept? Y-intercept. What do we do to always find a Y-intercept, guys? Plug in 0 for X. So plug in 0 for X. What do you get if you plug in 0 for X? 5. What is it always going to be the same as? The Y-intercept is going to be the same as what? C. Yes, because these are going to be zeros. All right. So now you guys are going to try this one on your own. Find all that information. The vertex, the Y-intercept, and also find that axis of symmetry. And check your answer when you're finished.